Hello techies. So today in this video we will be going to discuss about transistor and we are going to use transistor as a switch. So here you are seeing NPN transistor and this is the part number of this transistor. So you can check the data sheet of this and understand what kind of NPN is this. So the only point that you need to know at this moment is HFE. HFE is the gain from base to collector current. So that means this HFE varies from 270 to 680, which means that if your base current is, let's say, 1 milliamps, then your current collector current could vary in between 270 milliamps to 680 milliamps, depending on the collector resistor and the biasing at the base, all those things. So let's move to simulation. So in this simulation, what we are trying to do is I'm giving collector current source to the base, and this is a power supply voltage of 10 volt I have kept here, and some current limiting resistor, and emitter is grounded. So we want output to follow the input. So that means basically as a switch function, when some commands comes to the base, it says on, and let's see what happens to the output. And if the input says let's go off, then let's see what happens at the output. So let's run the simulation and let's check the input. So input is varying like this. Now let's check the output. So the output is 10 volt and 0 volt, varying in between these two. Okay, so the other thing that we need to notice is that input and outputs are complementary in nature. Depending on the circuit, what kind of circuit you want and what kind of functionality you want in your circuit or in your power supplies, you can modify all those things. So however, basic functionality is this only. So what happens is when the current is high, let's say 300 micro, so this transistor gets turned on. When this transistor gets turned on, the collector side becomes 0 volt in ideal case. However, there is a voltage drop in between, but in ideal case, let's say 0. So this becomes 0, so output is 0. And when this input is 0 amps, then this is floating, then there is no current passing through collector because base is 0, so collector will also be 0. In that case, we have a 0 voltage drop and we get 10 volt at the output. So the thing is, you can also vary the output in between a certain range by tuning this collector resistor, or controlling basically base current by either putting base resistor or varying this input current. But this is an ideal condition. So now what is the use of this circuit? So basically we are getting output which certainly follows pattern of input side. So let's say if any controller is there, microcontroller, and it is giving some digital signal, 5 volt, but not too much power in it, but you want this output of the microcontroller signal to control some other signal or switch, so you can use this thing. So now I'm trying to do is control the MOSFET. So in this circuit what you will see is I have put 5 volt pulsating input, which is coming from microcontroller signal. Yeah, and this signal doesn't contain too much power. So that is the reason we need additional power supply to drive this MOSFET. Since this transistor is in NPN and this is used as a switch. So now the simulation is already run. So let's see the input voltage. So input is oscillating between 0 and 5 volt, and I'm using 15 volt power supply through auxiliary power supply, which is connected to here. I have kept 1K because I don't want too much resistance in it, and also trade-off between power loss and all those things. I have set 1K in such a way that I get full voltage here. So let's see what is the input. So input is varying between, so as you can see, input and outputs are pulsate complementary in nature, and input is 5 volt, we get output 0 volt. So let's see if it is really driving the MOSFETs or not. So let's check the load current. So the load current is 5 amps. This is basically 0, and maximum current is 50 amps, which is following the Ohm's law. 50 volt and 1 ohm resistor makes 50 amps. Negative is because polarity of this resistor in LT spice, and this measures inside current, not the outside in voltage source. But the problem here is both are complementary in nature. So if we want any circuit that resembles the same output as the input, so what we can do is we can put another circuit, similar NPN transistor, and connect in this way. So this is the output. Now the output and output of this becomes the input of this transistor, and we get the same output. And since the input and output of NPN are complementary in nature, so which means that Vout3 will be similar to input side microcontroller output voltage. We get one complementary, these two are opposite, then we make it again complementary, then we get similar. So basically it's a 2 OR gate. Yeah, so let's see. Now input is 5 volt, and let's see what will be the output. So now you can see both are following each other, input and output. So complementary nature is gone. So there is a simple method or simple setup to make transistor as a switch, and you can drive a non-isolated gate which are on the same ground level. So I hope you like this video. So in next video I will try to discuss transistor as an amplifier, actually, because how we can use this transistor as an amplifier and what exactly does it amplify. So thank you.